Hey everyone, Mr. Fransky here. We're going to go over the blue packet in preparation for your 1-2, 1-3, 1-6 assessment coming up. This is going to go over some transformations of functions. This packet goes a little bit more in depth than the other ones, so I just want to make sure we have this down. So remember, the first thing we always want to do when we're given an equation like this is to clean the x. So I'm going to rewrite this as y equals absolute value. I'm going to take out the 2, and I'm left with then x minus 3. The reason I have to do this is because I have to make sure I'm shifting the right amount. So now what this tells me is if I do my RST, there's no reflection, so I don't have to worry about that because there's no negative in front or inside of the absolutes. Scale change, we have this 2 right here. That's going to be a horizontal, and it's going to be shrunk by a factor of 1/2. So normal absolute value looks like this. This guy is going to be skinnier. It's going to be moved in by a factor of 1/2. So whereas normally you go to 1, 1, now I'm going to be at 1/2, 1. And instead of 2, 2, I'm going to be at 1, 2. Okay? But we're not going to start from 0, 0, so I have to go back up here. So my translation is going to be right 3. Okay? So horizontal shrink by 1/2, and we moved right 3. So we move 1, 2, 3. So here's kind of my new origin. Now instead of going right 1 up 1, I'm going right 1/2 up 1. And then right another half and up 1. And so over 2 is going to be up 4. There we go. Okay, left 1 will be up 2. Left 2 will be up 4. Getting rid of my points. Left 2 up 4 right there. So it's going to be a skinny little absolute value graph with the kind of vertex of the thing right at 3 right there. All right, next one. I'll do my RST again. So reflection here, we have that negative on the outside, so it's going to be an x-axis reflection, right? Because things that happen on the outside change your y values. So if I change all my y values, that's going to be a reflection over the x-axis. Scale change, that 2 in the front, this is going to be, so that's outside of the parentheses. This is going to be a vertical stretch by 2. And my translation looks like I'm 5 left and up 2. So I'm going to go 5 left, up 2, puts me right there. That's where the vertex of my parabola is going to be. It's going to go downwards because it's reflected over the x-axis. Man, they do not like to leave my points. And so it's going to go downwards. Man. And it'll be stretched a factor of 2. So this is a good time to talk about, I really don't care if it's perfect as far as where the points go, as long as I see it's skinnier than it normally would be, right? Because it's been stretched by a factor of 2. So a normal parabola, the parabola would normally be over 1, down 1, over 1, down 1. So we've got to look something like that. This is going to be a little bit skinnier. So that's what I'm looking for. So as long as I can tell that you know it's skinnier, that's really the key. Cool. All right, next one. 1/2, absolute x plus 6 minus 2, RST. No reflection. Scale change looks like a vertical by 1/2. Translation is left 6 and down 2. So left 6, down 2. There's kind of my new origin. And let's see. This is absolute value, and it hasn't been reflected at all. So I'm just going to have a vertical stretch by 1/2, so it's going to be kind of skinny again. There it is. That's all there is to it. Okay. -2 absolute value of x plus 4 plus 1. So we've got a reflection here over the x-axis. On the outside, that's going to change all my y values. Scale change, looks like we have a vertical stretch by 2. And my translation looks like I'm left 4, up 1. So left 4, up 1, there's kind of my new origin. And now I have a x-axis reflection, so we're going down as a vertical stretch of 2, so it's going to be kind of skinny again. So something like that. Just a sketch here is just fine. All right, this guy looks like it needs to be cleaned, so I'm going to clean that x. So we have 1/2 times 2 times x minus 2 squared minus 1. All right, so I could leave it like this. This would be a vertical stretch by 1/2 and a horizontal shrink by 1/2 as well. But what I'm going to do is I'm going to square that 2 and bring it out. So if I square that 2, I have 1/2 times 4 times x minus 2 squared. Like that. 1/2 times 4 cancels out to a 2. So it's 2 parentheses, this is minus 1, x minus 2 squared minus 1. So that's the formula I'm going to use. I'm going to erase some of this. Well, I can leave it there. So 2 parentheses x minus 2 squared minus 1. So reflection, none. Scale change, we have that 2 out there. It's a vertical stretch 2. And then this minus 2 and minus 1, we are shifted right 2 and up 1. So right 2 up 1, there's our new vertex. And it looks like we have a no reflection, but scale change, we are stretched 2. So it's going to be kind of a skinny looking parabola. Something like that. Cool. All right. Next, we got -1 over x minus 4. I'm going to write it like this. Okay, so you see that negative is way out there. So my reflection here, that is an outside reflection, so it's going to be an x-axis reflection. Ooh. And my scale change, we don't have any. My translation is right 4. So 1, 2, 3, 4 right there. So that's kind of our new origin. Put some dotted lines in there. And we are reflected. So normally 1 over x is in quadrants 1 and 3. So like here and here. This, though, is reflected over the x-axis. So it's going to be here and here. That's all there is to it. Notice our vertical asymptote is now at 4. X equals 4 is our vertical asymptote. And the horizontal asymptote is still 0. Y equals 0. Cool. All right, moving right along. Next up, we got -x minus 2 cubed. So that negative on the outside is going to make us reflect over the x-axis. No scale change. Translation looks like we're moved to the right 2. Okay, so right 2, that's kind of our new origin. And we are reflected over the x-axis. So instead of going lane change like going upwards, it's going to be coming downwards. And that's it. So there we go. There's our graph. All right, next one. No reflection. Scale change looks like we have a vertical shift by a vertical shrink by 1/2. And our translation, we are going right 2 and up 1. So right 2 up 1 right there. This is cubic, and it's going to be stretched by a factor of 1/2, so it's going to be very skinny because it's been pulled up and down. So it's like you grab the ends of the arrows and you pull them in an up and down manner. All right, next up we got natural log -x plus 3. This has a reflection over the y-axis because the negative is on the inside, so that's going to change all my x values to the other side. Scale change, none. And my translation looks like we're moving left 3. So left 1, 2, 3. So this is my new vertical asymptote for natural log. Normally natural log would be on the right, but because we have a y-axis reflection, it's going to be on the left. There's our natural log. Nice. All right. A few more here. -x plus 3. Now this one's a little tricky because we have to clean the x. This is actually negative parentheses x minus 3. So our reflection is x-axis because that negative is on the inside. No scale change. And our translation looks like we are to the right 3. So right 1, 2, 3. There we go. So that's our new vertical asymptote. And we flipped over the, sorry, I should have said y-axis. Getting myself confused because all of the x values are changing, which moves it over the y-axis. So there is our new origin, and it's going to go to the left because it's been reflected. There we go. Something like that. Natural log is kind of a weird one, so make sure that you're getting that vertical asymptote in the right spot, and then you're having it go through the axis. It should be 1 on the side of the vertical asymptote, but I'm not going to check that too carefully. So as long as you're in the right neighborhood, I'll be okay. Okay, here again, they tell you to factor before translating. Right, that really just means to clean the x. So you have the square root here of negative parentheses x minus 2. So my reflection, on the inside there, so it's going to be y-axis, because the inside means all the x values will change, so it's a y-axis reflection. No scale change. And my translation is going to be right 2. So go right 2. And y-axis reflection, so we're going to move to the left with that square root function. That's all there is to it. Next one, we already have the x cleaned, that's nice. So my reflection, there is none. Scale change looks like a vertical stretch by 2. And translation looks like left 1, down 1. Alright, so left 1, down 1, that's right there. And then we have a vertical stretch by a factor of 2, so it's going to be a little bit taller square root than we're used to. That's it. Alright, words. See if we can use our words to describe these translations. So the first one looks like it's been moved to the right 20, and it's been moved down 7. No scale change or translation there. Next one, this is a vertical shrink by a factor of 1/2, because it's on the outside of the root. This guy's been moved left 3 and up 17. That's it, no number in front. This guy would be a horizontal stretch. And this is kind of weird. That stretch is going to be by a factor of 1 over 0.4. Okay, and 0.4, that is 2/5. This is 5/2 or 2.5. That's kind of weird because just remember, like, if you have the square root of 1/2 x, this is a stretch, a horizontal stretch by a factor of 2. You get that by doing 1 over 1/2, right? Because you multiply by the reciprocal, 1 times 2 over 1, which is 2. In this case, same deal. I just do 1 over 0.4, and that gives me the 2.5 or 5/2 that it's been scaled by. So it's a horizontal stretch. Next one, this is a reflection over the x-axis, because all the y values are going to change, and it is a shift to the left by 5. Nice. All right, so looking how to transfer from the graph of f to the graph of g. So this is the square root function moved right 7. This is the square root function moved left 4. So to get from the graph of f to the graph of g, let's kind of draw a sketch of this. So 1, 2, 3, 4, 5, 6, 7. So this is the original graph. And then we have 1, 2, 3, 4. That's the new graph. So what do we have to do to this? We got to move it left 11. That's all you got to do. All right, next one we got x plus 5 squared. We want to get to negative x minus 9 squared. So this is moved left 5. This guy's been moved right 5 and has been reflected over the x-axis. So what do we have to do? Well, we started left 5, we've got to be right 5. So we're going to move right 10, and we're going to reflect over the x-axis. That's all there is to it. All right, the next one, interesting. So this is a horizontal shrink by a factor of 1/4, and this is a vertical stretch by a factor of 5. But it looks like if we can just multiply this by 5 over 4, so multiply by 5 over 4, the 4's will cancel and the 5 will be there. And you can pull a number out of an absolute value sign, that's fine as long as it's positive. So, multiplying by 5/4, what that's going to do is it's going to undo the horizontal shrink. So basically what I'm going to do here is I'm going to do a horizontal stretch by a factor of 4. That's what this 1/4 does. And then I'm going to do a vertical stretch by a factor of 5. So we do a horizontal stretch out by a factor of 4, and then we stretch it vertically by a factor of 5. That's it. All right, more words. Graph of cube root of x is shifted 7.6 units to the left, then vertically stretched by a factor of 4.7. Then is reflected across the x-axis. They want an equation. So reflected across the x-axis means the y's are all changing. So I'm going to do RST here. So that's going to be negative cube root x. And then they say that it's been vertically stretched by a factor of 4.7. So I'm going to put a 4.7 in front of our cube root x. Then they say it's shifted 7.6 units left. So we have negative 4.7 cube root of x plus 7.6. That's it. Nice. Excuse me. All right, next one. This graph is horizontally shrunk by a factor of 1/4. So horizontally shrunk means that I'm going to multiply all the x's by 4, right? Because it's the reciprocal. So I'm going to have 4x squared minus 4 times 4x plus 3. Just leave it like that, right? So horizontal shrink means I have that 4 in front of each of the x's. Cool. Now we are horizontally stretched by a factor of 3. That's going to need a 1/3. So we're going to have absolute 1/3 x cubed plus 6 times 1/3 x. We can simplify that. It's not too bad, but that's all we have to do. All right. So what we have here is we have a graph of f of x, and they want us to graph f of 3x. So think about it this way. If you have like square root x and you replace the x, so this is f of x, then f of 3x would be square root of 3x. That 3 would shrink it horizontally by a factor of 1/3. Same thing's going to happen here. If we want f of 3x, we're just going to do a shrink horizontally by a factor of down to 1/3. So instead, 0, 0 is still going to be there, because a third of 0 is just 0. 1, though, is going to be translated back, right, because we are shrinking horizontally by a factor of 3, so it's going to go down to 1/3. Just dividing these all by 3. 1/2 divided by 3 is 1. I gotta think about that. Hold up. 1 went down to 1/3. 1.5, which is 3 halves, divided by 3 is 1/2. So we got a 1/2 there. That's at 0. Yep. Okay, so we come up and then we come down like that. Now on the left side, let's see here. Looks like we hit the point -1, -2. So that's going to come in by a factor of 1/3. So at -1/3, I'll be at -2. This is just going to go down like that. Nice and skinny because it's been shrunk horizontally by a factor of 1/3. Couple more here. So same graph. They want us to graph negative f of x plus 2 minus 1. So my reflection here is going to be over the x-axis, because it's going to change all my y values, that negative out there. Then the translation is down 2 and left 1. So I'm going to move this thing down 2 and left 1. This is kind of our new starting point, our 0, 0. I'll make an axis there so we can see what we're doing. Now, we are reflected over the x-axis. So this thing that's right 1 and up 1, it's going to be now right 1 and down 1. All right, so it connects there to there. And then 1/2 0 is now going to be at 1/2 -2. So that takes care of that part. Now on the other side, we said we went to -1, -2. So I'm going to go to -1 from our new origin and up 2 right there. And there's our function. Now they want 2f of x plus 1. So this time we have a scale change, a vertical stretch of 2. And we have a translation. We're going left 1. So we go left 1, and there's our new 0, 0. We're doing a vertical stretch by 2. So instead of going right 1 and up 1, I'm going to go right 1 and up 2. First thing. And then where we had 1.5, 0, I'm going to do that from, let's see here. Yeah, the vertical won't be affected, and it's just left 1, so it's going to be right there. And looks like that line is straight. And guy over here, now we got to go, usually we would go left 1 and down 2, so I have to go left 1 and down 4 this time. Because we have a vertical stretch by 2. Skinny again. Nice. All right. 1 plus f of negative x. So that f of negative x, that's going to be reflection over the y-axis. And that's because it's going to change all the x values, which is going to shift the graph over the y-axis. And then we have no scale change. And our translation is moved up 1. All right, so let's see here. So up 1, and we're flipped upside down. So that thing's still going to, sorry, flip to the left. So we're going to go left 1, up 1. And then we're going to go left another half and down to 1 again. Something like that. And then from here, we've got to go right 1 and down 2. There we go. Same graph, just moved up 1 and shifted over the y-axis. Cool. All right, so that's it for the blue packet. Hopefully it was helpful for you. You got one or two problems that you didn't have before. Love you guys. That's why I'm here. Have a great day.